Hello guys, welcome back. So in this video we are going to understand another level of this question. That very first we have seen already level 1, right? Queries 1. Now this is the question we have is XOR after multiplication, and we have level 2. Okay, the question is saying that we have given nums we have given, right, and queries we have given. Okay, so for each query we know that this is your start. We will start at L. Repeatedly we'll jump how many times? K times, right? And we have to multiply, that is with the V, and we have to take the modulus. That we have already talked about this in the very first version of this problem. Okay, so at the end we have to return the OR operations. We'll apply the XOR of the all numbers which is remaining, right? We are not doing the deletion here. We'll do the multiplication, right? So we'll do the XOR operations and we'll process the query. You know how I have updated the nums, remember? If you remember, if better, you'll go and see the queries 1 videos, and then you come to here, then you will understand clearly. Okay, what I'm trying to say, we'll build these things that we have seen in the last video, right? And then we'll return the queries. Okay, this is the things we have given. Let's understand the queries. So examples are same, different, no changes are the example. As you have seen, these things we have given, we have seen output is coming 4 after applying all these, right? We have seen. Similarly, if you talk about the example 2, we have seen it was coming 31, right? Remember, these two things we have done. Now talk about the constraints. So this time constraints are large. Okay, when we talk about the n, right, it is going to the power 5. If you apply based on these constraint, so the naive approach will happen, right? Because for every query we'll walk the indices that could give that will give you what n into q, and which is 10 to the power 5 and 10 to the power 5. That will be what, 10 to the power 10, right? Which is very big, means the way we are going to do optimize, but this is going to be very far, very big, right? So it is not worth to go check indices by indices, right? That is not worth. So what we should think, just split the queries by step size. Okay, so if this part of queries, let's suppose we have given, what we can do, we'll take, let's suppose where it is here. So we know that this is left and right, we have k. Okay, so if k is large, let's suppose we can say 50,000, right? So each query touches a very few indices, and it's cheap to do directly, right? So what we will do, if k is small, let's suppose k equal to 1, right? Each query touches a lot of indices, and doing this one by one for every query is become too slow. Understand? So we will separate the query into, give me 1 second. So I was saying, so if we talk about this k, okay, so k, if we are taking, let's suppose 5,000, right? If we are taking k is equal to 5,000, right, means for each query, right, it will go for all the indices, means few indices it will touch, right, for each query. That is, it's a cheap to do directly like this, right? But if we have k is less than 1, means it is a small, this is large, right? So when k is equal to 1, means it will touch, the query will get touched by how many times? Lot of indices, right? That we have seen in the very first part of this video. Okay, so what we will do, we'll do one by one query, and that will give you, each time it will touch all the indices, and that will become what, very slow. So what we can do, based on the given things, what we will do, we'll separate the queries into two. The very first is the, we'll call it is a large step query, and another will say the small step, and we'll say query. Okay, so the large step query we will apply directly, right? But when we talk about the step, a small step, right, here we'll do the batch wise. You know, if you understand the batch wise, means we'll batch together you can say, if you are clever, right? So cleverly we'll use the batch in the chunks, right, in the blocks, and then we'll apply. And if you not clever, you will directly apply this one. What you can do, you can directly, we can separate the query into large step and small steps, right, in the queries, right? So each queries we will apply. Let's suppose, so if we have the square root and we know the decomposition trick, what is square root decomposition trick is what? Let's suppose we have b. So if let b is the square root of n, right? So if b, not b, if k is greater than b, so each query we will touch at most how many times? Think, just do n by k, right? So at most n by k times it will do, right? And if it is less than root of n, right, so each query will touch at most what? n by k less than root n indices, right? And it will give you what? If you'll find the total work across all the queries, right? Say total work, okay, across the query will become what? Is less than equal to n, and you will multiply with the all n, it will become n into square root of n. Can we say that? Now think, if the k is less than equal to b, very first, when k is greater than b, if k is less than equal to b, in this case we need a smarter way. Understand? This is the approach we'll do. Okay, let's understand the intuition. Okay, so think about the given query. We have L, R, K and V, right? So if we'll take this query with a small steps, let's call k equal to 2. Okay, if k is equal to 2, we can consider this as a small steps, right? And this is our query. So can we say it multiplies nums at L, nums at L plus 2 and comma nums at L plus 4, right? Like that until we go where? Less than equal to the right. This is the thing we have given. So if we will apply on the queries that we have given left, right, k and v, and if we multiply with the small steps, right, we can say these are the chunks we have given, right? And it will go till the right, right, until right. That is exactly one lane in an array, right? So the lane of indices congruent will come what from is k. Can we say that? If it is your L, will take the mod k. Okay, so this will give you one lane. Understand? In an array that we have seen. Then what we should do, we should partition the array into some lanes, right? Can we say, if we given array, if let's suppose the nums we are talking about, okay, if we'll partition the nums into array into array nums lanes, right? So one array can be partitioned into multiple lanes, right? Can I say, give me 1 second to clean it, can I say, let's suppose for what we have given, k steps we have given, for steps k we have the array nums and we'll split into how many lanes? K lanes, right? Let's suppose we'll talk about the length 0. So for length 0, indices will take what? Okay, we'll say 0, k, 2k, 3k, and so on. Can we say that? When we talk about length at 1, the indices will become what? 1, 1 plus k, 1 plus 2k, and so on, right? This is little mathematically, so you should understand the concept, right? How we should build the concept, right? You should not jump that I am not understanding, right? Have some patience because you are doing the DSA, right? So if you're doing the DSA, you should have some patience to understand the concept, because contest questions will be hard, right? But you should understand how the you have to write the code, right? Because if you understand the concept little bit, right, if you'll keep pushing yourself, right, you will one day you will understand how to implement it. Okay, so let's understand. We have len 0, we have len 1, we have 4 k steps. So each query will affect one continuous segment, right, inside one lane. Can we say that? Means for every lane, right, the query will affect with the one continuous segment that we are talking about, right? So one continuous segment, it will affect based on the given things, right? Then very first step, let's call this step 1, where we will partition the array with some lane, right? So if we have given the nums we have given, and from the k we have given, right? So we will convert into k steps, and the very first step is will for each step k will convert into lanes, right? And the indices will become like this: 0k, 2k, 3k, and another lane will become 1 plus k, 1 plus 2k, like that we can say. And for each query it can go multiple k, we have multiple k lanes will be happen, right? So for each query, the only thing is to consider is it will affect one continuous segment inside each lane, right? Now think about step 2. This is your step 1. You can keep writing your notes book. Okay, now think about the range multiplication that we are talking about, right? Range multiplication tricks. Now the problem reduce in what? In a lane array, right, where we'll apply the multiplication updates to the range. So this is a classical, if you remember, if you do the right, the difference array. So difference array is a classical trick for the multiplication, right? If you're aware with that, it's fine. Otherwise, what I will do, I have planned already to write in a Fang series. So I have already created a Fang playlist where I used to write the I used to upload in very detailed videos in the Fang playlist. So I'll suggest, if you are preparing for the Fang preparation, keep subscribing the channel as well as keep watching whenever I upload in the Fang series. Okay, so we'll get the concept like this. Okay, so I was talking about, so now our range multiplication tricks is a problem, is a trick also. So that is now reduced. Now it become the lane array where we'll apply the multiplication update to the ranges, right? So this will become a tricky classical problem where difference array we will use, difference array tricks we will use for what? For the multiplication. Okay, so to multiply, what we need to do, we have to take a range from left to right. Can we say that? And we'll multiply by what? By v, right? So if we will write this, can we write this? We have some difference from the difference array, and this is nothing but your left bound. You will multiply with the given value. Similarly, you have the difference array contains at right bound, we'll say r plus 1 will take multiply equal to, will take the inverse of v. Can we say that? So we'll find the once this is done, we'll find the cumulative product of div, right? You know the cumulative product of div we will find, then we'll do, if you're aware with that. Otherwise, just think that once you will find this these two things, right, then you have to find the cumulative product of div, right? That gives you the multiplier at each position. Understand? Those things we will do. You can write in your notes. Okay, so why we are using the inverse here? Because we need to cancel the multiplication after each position r. Okay, so at each position r, we need to cancel the multiplication effect, right? Like you remember, we'll do something, let's understand how, right? If you do the sum difference array, right, and then you subtract after applying that. Let me show you how. Or you remember like how the difference array we subtract from r plus 1, right? If you remember that, we can do that. Okay, just think, let me know in the comment section you understand or not. Okay, so after we swap through the lane, right, once the prefix sum product created, right, for each index we'll get the commutative multipliers, right? I'll show you the code, then you will understand. Okay, so this is why this code will work. Who is on the gate? Let me check. Sorry, somebody was on the my main gate. Okay, so very first we understand we have to take the large k and the small k. Whenever we'll talk about the large k, it is cheap because we have to go for the all the very few position, it will be touch. But when we talk about the small k, many queries will be touch in the array, right? It will touch the array. So when we project it into lanes that we have seen, right, we have done that. So it give you the range update, which can be batch with the multiplication difference array that we have seen here, and we'll combine both, and that will give you the optimal answer, right? So very big picture if you talk about, so we have what we need to do. Just imagine the array is a city with the streets, right? And each step k defines a k separate lanes. You can say parallel roads are there, right? Give me 1 second. Give me 1 second. Okay, so just think that there is a city. Okay, there is a city we have given, right? And in a city we have some streets are there. Okay, like this, not like this, we can take a street like this. Okay, in a parallel. Okay, so for each step it is a step size k, right? We have a separate k lines, we have the parallel roads are we have, right? So each query on the lane x, let's suppose this is a lane x, right, will multiply all the houses between the position a and b, right? By how? Just multiply the v. Instead of visiting each house, we just mark where the effect start, where it ends. That we will do, and that is called your difference array. Understand? So at each end, we'll dive through the lane, right? And we'll keep applying the multiplication in order. Okay, I'll try to summarize this in the comment section, don't worry. Okay, let me know you are not understanding. Okay, let's understand the code, how we are going to write it, because talking too much is not good. Okay. So as I told you, we'll talk about this is the mode power. You know how to implement it, you should understand. If you're not, let me know in the comment section. I'll create another video to make you understood. Okay, then we have this function we have given, where we have given two things, nums and queries we have given as per the example you have seen, right? So very first, what you need to do, you have to define the block size, right? And then you have to group the queries by step by k, right? How we are going to do, for you will go for all the queries from 0 to the block size. You know, if you take the square root, what is the maximum byte, that you will get the square root of the size. So you will get the you have to find the query wise steps. So we'll keep updating the query wise steps in the list of integers. Okay, then you have to create the separate query section where we will process the query. You will find the left bound, right bound, steps, and the multiplier. These things we have given, right? So each step, if you'll check if it is greater than this, then you have to apply directly. I will say this is the large step. You remember I told you to you have to convert into two blocks, the large steps queries and the small steps. So small steps you will keep updating like this, and this is your larger step where you will directly you will do the multiplication. You will get the value. You just need to do what? Mod. Let's suppose this is your 5000 thing, right? When k equal to 5000 and when k equal to 1 or 2, we can say. Okay, so these two things will apply here. Then for all the steps, right, what you need to do, you have to check if it is empty, steps is empty. You just don't need to do anything. Then you will get the remainder, right? How will get the remainder? You will find the remainder, then you will have the start and end, and you know that this is your remaining bucket where we have to find the things. You will just pass these things, right? And your remaining blocks are there. So you'll keep finding all the remaining buckets, right? And once you have the ready the buckets, you will apply the things where you will get the remainder. You have to find the update, right? And you apply the difference array tricks, right? And you will find the, this is your sequence, how to find the sequence, right? And initially you will fill with the 1, right? You will try on the update. So what you have to do, you will get from the entry set, you will get all the updates, right? So from here you will get the updated one and the inverse multiplier that we have talked about, right? The two things will get, okay? And then you will multiply both of them, right? And you will find the cumulative product, right? Once you find the cumulative product, right? If it is condition, you have to check the conditions also, okay? So just like that, we will find the difference array, cumulative product we will find and we'll update it, right? To find the cumulative update, we have just created the difference array. Our difference array is prepared. Now, initially you will define the cumulative product and you will create the cumulative product here, where you will have the both product you have, and you will keep applying multiplying this, right? And you have to update our nums, right? Once your nums you will update it, right? Just you need to do what? You will apply all the XOR operations, right? And you will return the result, okay? So I will put these things that I will tried, right? Very first you will have the nums we have, right? Where you have the queries we have, you have convert into 2 blocks, right? Because we have to define it, right? So very first queries we have is query 1A and queries B we have. So queries A will talk about when k equal to we'll take small steps, right? So we can process the smallest steps by k, and we'll say we'll process k with, there will be 2 lanes will be there, and we'll find the R0 and R1 like this, okay? And you will find the remainder, start and end, those things you will find, the lanes you will find, right? You will find the difference array, right? How will you find the, you will have to apply the values, right? You will apply the difference, right? And the difference at 2, you will then you will do the inverse, and you will get the value, right? Then you need the previous product values, and once this is done, right, your array is ready after the cumulative product, right? This is your cumulative product, okay? Then you just need to apply on each lanes, right? These are the queries we have given, this is the difference array we have, and we have the marks we have, right? So you will find the all the product, your array will be ready, right? Then what you need to do, you will apply on the XOR. Once you will apply the XOR, you will get, it is giving 31. So little tricks are different, right? I'll put the code in the comment section, you can get it from there, and let me know in the comment section that you will understand or not, right? I know this is a little hard problem, so you just debug this code, you will understand everything. Anyways, thank you for watching this video. I'll try to keep everything concise in the comment section. I'll see you in the next one. Thank you. Please like, subscribe the channel.